Okay, we are now on 3.2, still solving systems. We stopped dramatically in the middle of a lesson for part 1, and now we're on to part 2. If you notice, one of the big things here is this is not substitution anymore. We have left the substitution world and we need to go into what's called elimination. So I need to teach you how to do elimination or remind you how to do elimination. So we'll come back to example 6, so leave a little space in your notes. And let's do example 7. Use elimination to solve the system. All right. Now, one of the things with elimination is you're trying to eliminate a variable so that you solve for either x or for y. For y. So what I'm going to do here is I have x plus 2y equals 10. And I have x plus y equals 6. And I want you to think back in the day when you would add, like column format, you'd add it down. I want to do that as well. The only thing is, when I do this, I want something to eliminate. So if I add the way they are, x plus x is 2x, 2y plus y is 3y. I'm not eliminating a variable. However, if I change my signs on just one of these equations, like this, take this entire equation times -1, which in my world is switch, switch, switch. Now if I add column y's, I have x plus -x is 0. Well, I'm not going to bother writing 0. 2y plus -y is y. And 10 plus -6 is 4. So I have y equals 4. All right, well that was fast. You're like, whoa, I got y already. Well, now you need to go back and find x. And it doesn't matter which one you put it in. I think this one looks a little bit easier. So now I'm going to write out x plus y, except in place of y, I write 4. And that's equal to 6. So now I solve, most of us know by looking at that, x is equal to 2. So the solution to this system is 2, 4. And we've used elimination because in this process, the x is eliminated, and now we're down to just a y. All right, let's try another one. Example 8. This one already sets up. Look at, if I put a big plus sign here, and if I add column ways, I don't have to switch any signs because the -x and the x will automatically cancel. So this is gone. -3y plus 5y is 2y. -5 plus -3 is -8. So y is -4. Now I have to go back to one of these equations and put it in. It does not matter which one, but I'm going to go for the second one. So I have x plus 5y, my y value is -4, is equal to -3. So x minus 20 is equal to -3. X is equal to, when I add 20 to both sides, I get a 17. So my intersection, if I were to graph this, or the solution to this system, is 17, -4, because I put the x before the y. Example 9. All right, this one doesn't work out as nicely, because if I were to just switch my signs, x's don't eliminate and y's don't eliminate. So it's not going to be as simple as just multiplying by a -1. In this case, I am now going to have to multiply by a number that will allow me to cancel out. Now, 2, if I take this top equation times 2, then this will have a 2x and this will be a 2x. However, 2 is not quite enough to get me to a 0, because 2x plus 2x is 4x. So what I need to do, I guess I really didn't need to do this particular step, is I need to take everything here times -2. Watch what happens. If I take this equation times -2, I have -2x plus -6y is equal to -14. And then I'm going to rewrite the second one the way it is. Okay, these cancel out now. -2x and 2x are gone. See how that worked? I've eliminated my variable, hence the name elimination. This becomes -1y, or -y is equal to -4. Well, if -y equals -4, y equals 4. I can go back to either one of these and put it in. I think this one looks slightly easier. So I'm going to have x plus 3y, which is 4, is equal to 7. So x plus 12 equals 7. X is equal to negative 5. So x is equal to negative 5, y is equal to 4. There's your solution to your system. And what would be good is if you go back and check it in the equation you didn't already substitute in. So if you go negative 5 here, that gives me negative 10. Put 4 in for y. 4 times 5 is 20. Is negative 10 plus 20 10? Yes, it is. So we know that this is a solution to both systems, or both equations. Example number 10, use the elimination method to solve. Well, this one, 2x plus 3y equals 12. 5x minus 2y equals 11. Well, shoot. I don't even if I multiply this times 2.5, or am I going to multiply the bottom one times 1.5? We try not to do those. Keep it just multiplying by whole numbers. So here's one way. You either look to get rid of the x's or the y's. If I want to get rid of the x's, what's the number that goes into 2 and 5? 10. Okay, so I would have to multiply this one times 5, this one by 2 in order to get 10, and they would cancel out. Or, if you're really thinking ahead, I have a 3 and a 2. 3 and 2 both go into 6. I like that slightly better because then my number's not quite so big. So I would have to take the top equation times 2, the bottom equation times 3, and then my y's will cancel. So here's what's going to happen. Here's what it looks like. Take this equation times 2, take this equation times 3. And if you wanted, and I don't really want to spend the time, but I could show you, take the top equation times 5, the bottom equation times negative 2, and you'll eliminate your x's. Well, I'm going for the y's. So 2 times 2x is 4x. 2 times 3y is 6y. 2 times 12 is 24. I have more kids forget to take 2 times whatever is over here, so make sure you do that. 3 times 5 is 15x. 3 times negative 2y is negative 6y. And 3 is equal to 3 times 11 is 33. Wow! Negative 6y and 6y cancel out. I got a big 4x plus 15x, which is 19x, is equal to 24 plus 43, which is 57. Okay, divide both sides by 19. I do believe x is 3. Okay, go back. I think I'm going to go with the top equation here. 2x, instead of writing x, I write 3, plus 3y equals 12. Now I solve for y. 6 plus 3y equals 12. 3y equals 6. Y equals 2. So now I have x equals 3 and y equals 2. The solution to the system is 3, 2. All right, I've got another one of these just because these are probably the toughest of all of the ones we run into. All right, so I've got a negative 3x plus 5y equals 12. 6x minus 10y equals negative 21. Okay, this I could do by multiplying the top equation by 2. I think that's what I'm going to do. Take this equation times 2. So now what I really have is negative 6x plus 10y is equal to 24. And down below I have still 6x minus 10y equals negative 21. Oh my gosh, look what happens here. This is gone. This is gone. So my left side of the equal sign is 0. 24 minus 21 is 3. Whoa. Can 0 equal 3? No way, Jose. All right. So if that's not possible, what kinds of lines have no solution? Wouldn't that be lines that never intersect? Those would be parallel lines, okay? And what is the name for that? They would be inconsistent. Oh yeah, those words. So you have to remember that that's an inconsistent situation that we've got going on right here. Example 12, let's look at that as well. 2x plus 3y equals 11. We've got negative 4x minus 6y equals 20. All right, I'm going to take the top equation times 2. Now let's see what happens when I do that. 2 times 2 is 4. 2 times 3 is 6. I got a 6y equals 22. Down below I have negative 4x. I have a negative 6y equals 20. cancels. I have 0 equals 42. No fun. The exact same thing happens. I have a inconsistent situation. Okay, anytime you see that, you're like, huh? 0 doesn't equal 42. Well, I have no solution. I have parallel lines if you were to graph that. All right, let's go on. Let's see if we get something. Oh, nope, that's not what I want to do. I want to go back now to example 5. And I think I need to wrap up one other thing. Okay, example 5. Here you go. Look at what this is. This is one equation. This is another equation. If I take this entire equation, I don't know, do you want to take it times 265? Or how about 320? I don't know, I like the number 320 better for some reason. So my system now is 265x plus 320y equals 13,930. And then down here I have 320x and 320y. Oops, guess what I forgot to do? I'll show you a quick fix. Whatever 320 times 48 is, grab a calculator. You're like, I don't have my calculator when I take notes. I hope Mrs. Talley is just going to do it for me. Oh, here I am, giving it 15,360. But here's the kicker. Nothing is still canceling out yet. Okay, so if you come across this, you multiply, you're like, nothing's canceling, but I have the same number. Then let's go ahead and switch signs. Switch, switch, switch. Gone. So 265 minus 320 is negative 55x is equal to 13,930 minus 15,360, negative 1430. And then when you solve for x, you get 26. Okay, I think this one looks way easier than the other one. So 26 plus y equals 48. And that's going to give me 22. Okay, now what does this mean in terms of the problem? Oh, yeah, that means how many of each chair were sold. Well, that means they sold 26 rocking chairs and 22 Adirondack chairs with the footstool. Okay, let's do another one here. Example 6. Amy's Amusement Park tickets sell for $24.50 for adults and $16.50 for children. On Sunday, the amusement park made $6,405 from selling 330 tickets. How many of each kind of ticket was sold? All right, once again, I'm going to do the money thing, and then I'm going to have the amount. So adults sell for $24.50, and if you want to be sneaky, you can put an A in there, plus $16.50 for children, so I'm going to put a C, and the total amount that was taken in was $6,405. On Sunday, the amusement park, they sold 330 tickets. So the adult tickets plus the children's tickets equals 330. And there's your system. And I'm going to leave you to finish this one. So you're supposed to finish example number 6. Meanwhile, I'm going to jump ahead to touch one other piece of information. Remember how these were inconsistent? All right. I don't have another one here, but what if you were to solve it out? Like you would do all kinds of work. Here's your system. You solve, solve, solve. You get down here and you get a point that says 3 equals 3. Or you get 0 equals 0. When you have those kinds of situations, anytime, sorry, I just took that off the screen. Here we go. Try again. 3 equals 3. Or 0 equals 0, or negative 2 equals negative 2. That is when you have lines landing right on top of each other. Okay, so you would say they are dependent and consistent. I had to think for a little bit. What were the words that I wanted to use? Okay, if you get answers like x equals 2, m equals 3, or if b equals negative 17, or even x equals 0. Be careful with that. Sometimes kids think when x equals 0 is not an answer. Anytime that happens, you have lines that are doing this. Make sure this little, it's not really a table, I should probably put it together in a nice little table, into your notes. That means they're independent and consistent. Okay, one line's going one way, you have an actual solution. And the last thing we just talked about is if you have 0 equals 4, or 2 equals -8, or 3 equals -3, if you have that situation, that's when your lines are parallel. And then you say you have an inconsistent system. And I feel better now that you've kind of got that in your notes to kind of look back on. And the hard thing is going to be remembering what terms go with that. And maybe I'll come up with something for this so that we can, I don't know if that's something that needs to be memorized, but we should at least have a sense. All right? And that is the end of the lesson.